Hello, welcome to another Rocket League data analysis, and this data analysis is brought to us by Kaggle.com. And if you're into data science at all, definitely would recommend Kaggle.com. It's free to register, just pop your email in, do all that sort of fun stuff. And it has all these cool things for any budding data scientist or nerd like me. You got data sets of damn near every topic, you have competitions you can participate in, you have the other people's code you can steal, borrow, reference. I'm kidding. But at the same time, like, you can use other people's code for inspiration and to kind of like develop, like, tweak their code into your own projects. But jokes aside, this is a really good website. And one such competition was the Tabular Playground Series in October 2022. Which is right here, and I'll link this article in the description here. And this is one person's submission where he used a really fancy machine learning technique. This is brought to us by Infrared, who he or she is just way smarter than me in all walks of life, because I don't even know half the stuff that's going on here. But you know, we're gonna look at some cool things and hopefully learn some stuff. I obviously did not do any of this. All credit goes to Infrared. I'm just here showing it off because I think it's really cool, and hopefully you think it's cool too. So basically, the data set gives a bunch of data, and it's like a snapshot of a Rocket League game. So everyone's position, velocity, ball position, that kind of thing, and you have to predict whether or not a goal will be scored in 10 seconds, and which team will score the goal, Team A or Team B. So for all intents and purposes, we're just going to say Team A is blue and Team B is orange, even though I don't know if that's actually the case in this data set. Let's take a look. We're not going to go through the whole article. I will link it, and I do recommend you read it. But we have all the columns here. You have game numbers, ball position, ball velocity, X, Y, Z. X is how left or right you are on the field. If you're looking at it from Blue's POV. So negative X is to the left, negative or positive X to the right from Blue's POV, and then Z is up in the air, and Y is, if it's positive, it's on the orange side, if it's negative, it's on the blue side. You have all this data, and now we go into some of this stuff I'm just going to skip over. You can look at your own time, but it's just like looking at time between goals and stuff. Now here's where we get to the interesting part, in my opinion. We have ball position when Team A, we'll just say blue, scoring within 10 seconds, and then ball position when Team B, say orange, scoring within 10 seconds. And you can kind of see it's pretty similar, it's pretty flipped, but you have a lot of concentration on the other team's side, obviously, when you're like getting pressure and stuff. And then you have way less concentration on your own side, and then you have this little like blob in the middle, which I imagine is for kickoff goals. So I thought that's really cool, and it kind of makes sense intuitively, right? If the ball's on the other team's side, you're more likely to score a goal at that time. So now we look at player positions when their team scores, and these red graphs are a little hard to see, I will admit that, but you can even kind of see, like, these are just. The really cool thing about this that I thought is these are just snapshots of Rocket League games, of just positions of cars, and you can even see the boost pad lanes here in the graphs of just all these snapshots of players' positions getting put on top of each other, and you can literally see the boost pads. That's so cool. That's so cool how it just worked out like that. And then now we have the positions when the other team scores. And you can kind of see, these red ones are still hard to see, but you can kind of see, like, if you look at these blue ones, most of the time they're like on their own side. They're like not on the pad lanes as much on the other side. So it kind of, like, if you can compare, like, when blue team scores here to when blue team gets scored on, you know, it's a lot more like field control when blue team scores, and a lot more defensive when they get scored on. And kind of reverse for red team, but it's hard to see. So now we look at all the player positions. This is all the player positions of every single situation, and you can clearly see these boost pads. You can clearly see these this corner kind of diagonal rotation to the middle. This could also be off kickoff, so one person goes back, and you just kind of have these pad rotations here. You can kind of clearly see them, which I thought that's really fascinating. And then we have this green is the ball position. The ball actually spends a lot of time on the wall, it looks like, from these snapshots. And then again, we have this blob in the middle for kickoffs. So now we look at the distribution. So Team A scoring within 10 seconds, about 6%. Team B scoring within 10 seconds, about 6%. Team A is blue, Team B is orange, if I just refer to those just interchangeably, even though I'm not sure if that's what it actually is in this data set. Anyway, now we look at this big mountain here, and this basically is a correlation heat map between all these variables, and it's really hard to see. And even though I zoom in, it doesn't really help anything. It's really hard to see, but basically, it's like each cell is a correlation between the row and column. So here we have player 1 X position is 0.6 correlated with ball X position. So you can kind of see how the ball position would influence the player position and stuff like that. And I do recommend going in and looking at this if this fascinates you. I'm not going to go through the whole thing, and it's probably really impossible to see this on YouTube. So just it's there. And then now we have more correlations. But now I'm going to zoom back out a little bit. And of course you have all this Python code if you want to remake it. Okay, so I thought those graphs were really interesting, and the rest of the stuff is a little over my head. I will admit that, but basically how he actually builds, or she actually builds this model is puts the training data set into all these different models and gets a weighted average and predicts a probability whether or not a goal is going to get scored. So you can kind of see there is some Python code here you can look at, and then so each data set, there's 10 training data sets that were provided with this competition, gets fed into a different model. Each model predicts a probability, and then and then the testing data set. So I should mention this, okay? So I don't want to get too ahead of myself. Basically, when you build these models, you split your model into a training data set and a test data set. Your training data set is basically the data set you use to create your model. And it will have all the data will have yes, a goal was scored in 10 seconds. Your testing data set will have the same, but you run that through your model and you see how accurate it is. And you want to be careful about not having something too accurate, because if it's too accurate, what could happen is you're doing something called overfitting, which basically means for your data set, your model works really well, but only for your data set. And in practice and in the real world, it won't work as well. So you don't want to be super accurate, but you want to have this nice balance of actually being accurate and not just making sure you're not overfitting. But anyway, so how this all these models will work is that each training data set is used to build each of these models, and then we run the test data. Every single snapshot of Rocket League of the test data gets fed through every model, and then each model comes out with a predicted probability of whether or not a goal will get scored, and then you do the weighted average to get your final prediction, and that would be the final submission. And again, you can do all this in Python if you want. And then we have these feature importance graphs, which basically is a measure of how significant a column is to whether or not a goal gets scored. And he created some other variables such as Team B defending, Team A defending, ball position X and X, and stuff like that. So yeah, I think this is a really interesting read, and I really think those graphs are really cool and some of these machine learning concepts. I'm not going to waste too much of your time, but I do recommend reading this. It's really cool. See ya.